Hello my dear students, hope you all are fine and obviously in high spirit to learn 11th physics. Today we are going to deal with the chapter motion in a straight line. In the first we shall discuss about motion. In 9th class itself you might have studied about the motion. The motion says that a change in position of object with respect to time. Moreover, motion in a straight line. So, this also implies that we are going to emphasize on straight line only. Motion may be in common motion while we are running, walking and riding bicycle, also that is a motion. This study of motion is called mechanics. Under mechanics, we have got three subsections, that is statics, dynamics, and kinematics. Statics is the study of objects at rest. When the object is at rest, then also some science is related to that. That study of that science is called statics. Let us consider an object is lying in a plane surface. Here W is equal to mg downward, and we know that a counter force is applied upward from the surface, that is reaction. This comes under the Newton's third law of motion, that is every action there is equivalent opposite reaction. If it is the case in an inclined plane, let us consider an object is placed in an inclined plane. The vertical weight will be W is equal to mg, and the reaction will be perpendicular to the surface, that is reaction R, and if there exists any resistance, that may be obviously opposite to the direction of the sliding, that is F. So, there is lot much to study about the statistics. Next we shall discuss about the dynamics. Dynamics is the study of objects in motion by considering the cause of motion. So, dynamics is the study of objects in motion considering the cause of motion. We are not at all considering the motion, but we are also considering the cause for that motion also. Let me give one example here. A box is there, a suitable force is given. So, accordingly the box will have the tendency to move with some velocity v. So, in this we will be studying about the velocity as well as the reason for the velocity gained by the object, that is force. So, ultimately the branch of mechanics which deals with the study of objects in motion by considering the cause of motion. Next comes the kinematics. Kinematics is again study of objects in motion without considering the cause of motion. Without considering the cause of motion. That means here we will be considering the motion only, not the cause by which the object is moved. So, collectively saying mechanics has got three branches: statics, dynamics and kinematics. We will be focusing, as this is relevant to the topic, that is lesson, that is motion in a straight line, we will be concentrating this kinematics only. You might be having idea about the equations of motion which you might have studied in class 9th, that is V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS, where V is the final velocity, U is the initial velocity, and S is the displacement, and A is the acceleration. So, this is the basic formulas related to kinematics. Under kinematics, we are having three types of motion. Let us consider an object is falling. So, it is in one dimension only. So, it is called a rectilinear motion. What is the rectilinear motion? Means any object moving in a particular straight line, that is called a rectilinear motion. If an object is moving in a two dimension, that is xy axis, that is called planar motion. Let us have an example here. If a boy is throwing a ball, that will have a projectile motion, that is a two-dimensional motion. And the third one is motion in space, in which we are considering x axis, y axis and z axis. If a butterfly is flying in a room, the motion will be in a zigzag according to x axis, y axis and z axis. In order to represent the x, y, z axis, we will be able to express in x, y, z axis. Just like x is equal to 2, the position, here we may take this as 2, 4, like this 2, 4, and in this we have to represent in 3 dimension, say x, y, z. So, collectively saying types of motion, we have got 3 types, that is one dimension, that is also called rectilinear motion, in 2 dimension, that is in a xy plane, that is why it is called a planar motion, and the third one is the motion in space. So, it is called motion in space, that is 3 dimension. Since we are dealing with the motion, motion is what? Change in position. The word comes position. Until then we know the exact position of the object, we cannot go for motion. So, let us understand position, how it can be represented. Position is a set of coordinates by which an observer defines an object oblique event. So, set of coordinates is just now we have seen in some places we are taking x axis, in some in 2 dimension we are taking xy plane, and in 3 dimension we are taking xyz plane. So, in order to specify the object in xy plane, we need to have the exact position, say x, y. If it is in a straight line, say this is 0, 1, 2, 3. So, here x is equal to 3. In the 3 dimension, we will be having like this, similar to that, that is x, y, z. If the set of coordinates is incorporated by time, let us have a clock attached to this, that is the moment of the object is being attached with the time, then that is called frame of reference. Just now we have seen the position. The next topic is path length. It is also called distance. What is path length? It is the actual path traversed by the object regardless of direction. Suppose an object is moving from A to B and B to C. Let the distance be 10 meter and B to C is 5 meter. Then the total distance covered will be 10 plus 5, 15 meter. Similarly, we can take another example which involves the direction. Say a body is moving from A to B, B to C and make it D. Okay. So, A to B, B to C and again it is changing the direction towards D. So, what will be the distance in this case? A to B 10 meter, B to C 5 meter and C to D 2 meter. So, collectively 10 plus 5 plus 2, that is equal to 17 meter. In the both cases, you might have noticed that in the first case there is no change in the direction, the body is moving in a rectilinear path. So, we are adding all this. If there is a change in direction, then we might have got the change in distance here also, but we are not at all getting, since the definition says it is the actual path traversed by the object. Actual path means the path followed by the object, path followed by the object. So, this example gives an idea that it is regardless of direction. If the direction is changing, there is nothing changes in the magnitude of the distance. So, that is why we are getting distance is equal to 17 meter. So, what is the SI unit of distance? SI unit of distance is meter and it is the scalar quantity, since it is depending on the magnitude only, not the direction. And dimension, what is the dimension? It depends on the length only, that is path traversed by the object, length only. So, M0, L1, T0, that is the dimension code. Next, we shall discuss about the displacement. The shortest line separation between initial and final point. Let me remind, the shortest line separation between initial and final point. Let us take an example here. A to B 10 meter and B to C 5 meter. A body is moving from A to B and B to C. Finally, what we need here, 2 points only we need, that is, one is initial point, another one is final point. What is the final point here? C here, and what is the initial point? A. So, already it is in a straight line. So, we have to add this. So, 10 plus 5, that is equal to 15 meter. So, we can say the displacement here is 15 meter. Let us have another example. An object is moving from A to B, covers 3 meter, and B to C downward covering 4 meter. Here we need to calculate the displacement. For calculation of displacement, what we need? Just 2 points, that is initial point and the final point. Here the initial point is A and the final point is C, joining AC. So, we need to find the AC. What is AC here? Since it is a right angle triangle, it is a hypotenuse. So, root over 3 square plus 4 square. So, altogether we will be getting 5. So, 3 square 9, 4 square 16. So, 16 plus 9 25, root of 25 is 5 meter. So, in the initial case we have seen a displacement in straight line. In the second case we have seen the direction change and the displacement is changing, that is 5 meter. Let us take another example which is to be given in distance as well as in displacement. We shall calculate distance and displacement taking the same example. Let us consider a circle of radius 7 meter. So, the distance will be, a boy is covering a distance full circle, say this is the initial point and take it as this is the final point. Again the boy starting from here and ending at the same point. So, the distance here will be 2 pi r, since it is a circle. So, circumference of circle is 2 pi r, 2 into 22 by 7 into 7. This 2 7 will get cancelled, we will be having 2 into 22, that is 44 meter. Apply the same example here. The same circle we are having, a boy is covering a distance A to B, and in the second case the boy is covering the distance A, B and coming to the same point C. So, in the first case A to B, so the distance will be 2 pi r by 2, 2 pi r by 2, say 2 pi r by 2. So, pi r. So, 22 by 7 into 7, that is 44. So, the displacement distance here is 44. So, what about the displacement here? In the first case he is following from A to B, the displacement will be the initial point and the final point. So, it is a diameter. So, 7 meter plus 7 meter, that is 14 meter. In the second case, the boy is covering the whole circle and come to the same point A, or name it as C. So, what is the initial point? That is A. What is the final point? That is C. The shortest distance is 0. So, the displacement is 0. So, this 2 example gives an idea that the displacement is depending on the direction, hence it is a vector quantity. It is depending on magnitude as well as direction, that is why we are calling it a vector quantity. The SI unit of displacement is meter. So, the unit of distance is meter as well as SI unit of displacement is also meter. There is no change in the SI unit. So, the dimension here, again the dimension of the displacement is also same, m0 L1 T0. Again these two are same, where it is changing, the SI unit is same and the dimension is also same, and it is a scalar quantity and it is a vector quantity. Since it is depending on the magnitude only, we have just seen that it is depending on the magnitude, not the direction. That is, it is not changing the magnitude due to the change in the direction. But in the case of displacement, if we are changing the direction, the displacement changes. So, we can say it is a vector quantity. In comparison with the distance and displacement, we should note some of the points here. One is distance is always greater than or equal to displacement. In other way, displacement cannot be greater than distance. Next point is distance can't be 0. whether if you go in same direction or in opposite direction or in any direction, distance is always added up, say 3 meter, 2 meter and 3 meter. The distance, total distance covered is 3 plus 2 plus 3, that is 8 meter. So, it is always added and it cannot be 0, but in the case of displacement it can be 0 when the initial and final point is same, then the displacement will be obviously 0, and if it is going against the direction it can be negative also. For that, let us see one example here. An object is moving from A to B covering distance 3 meter, and again it is moving from B to C, that is minus 2. So, what is the distance? Total distance covered is 3 plus 2, that is 5 meter, but in the case of displacement, here the distance is from initial position is A and the final position is C, and it is in the negative side. So, it is minus 2. So, we can collectively say the distance cannot be 0, it is always positive, and the displacement can be 0, positive or negative. Next is distance can't decrease with time. As the object is traversing the path, the distance is increasing, not decreasing. So, distance can't decrease with time, it is always increasing only. But in the case of displacement, decreases especially when it reaches towards the initial point. That means, when an object is approaching towards the initial point, the displacement is reducing. So, it decreases when it reaches towards the initial point. Next topic is speed. Rate of distance covered in time is called speed. Rate of distance covered means rate at which the distance is covered is called a speed, and the formula is distance by time. Let us consider an object is moving from A to B covering distance 25 kilometer in 1 hour. Another 1 hour it is taking 2 hours for 45 kilometer. Then what will be the total distance covered? The total distance covered is 25 plus 45. The total time taken is 1 plus 2, 3 hours. So, 70 by 3 kilometer per hour. So, the speed of the object is 70 by 3 kilometer per hour. It is a scalar quantity. Why? Because the formula is speed is equal to distance by time, and we know that distance is a scalar quantity. So, the speed is a scalar quantity. What is the average speed? Average speed is equal to total distance covered by total time taken. In order to calculate the average speed, let us again take an example. A body is moving from A to B, B to C and C to D, covering a distance D1, D2 and D3, taking time T1, T2, T3. So, what will be the total distance covered from A to D? The total distance covered is D1 plus D2 plus D3, and the total time taken to cover the distance A to D is T1 plus T2 plus T3. So, what is the formula? Total distance by total time taken. So, average speed is equal to D1 plus D2 plus D3 by T1 plus T2 plus T3. That gives the average speed of the object from moving from A to D. Next is velocity. Velocity describes about the rate of displacement, or we can say rate at which the displacement is taken place. The formula is V is equal to displacement by time, that is equal to x by t, where x is the displacement and t is the time taken. Since displacement is a vector quantity, just now we have seen displacement depends on the magnitude as well as direction, it is a vector quantity. So, obviously, velocity is also a vector quantity. Its SI unit is meter per second, that is same to speed. So, SI unit of velocity is meter per second and its dimension is mlt minus 1, that is meter per second that is L by T, that is equal to LT minus 1 m0. So, that is the dimension. Then what is the average velocity? So, in the every part of the displacement, the velocity is changing. So, in order to find the average velocity, we need to find the change in position and change in time also. So, V is equal to x2 minus x1 by t2 minus t1. So, x2 minus x1 gives the idea about the change in position of the object and t2 minus t1 gives the change in time. So, it can be written as V is equal to del x by del t. Next topic is instantaneous velocity. The name itself suggests that instantaneous means instant velocity, that is velocity of any object in motion at a particular instant of time. That means, in motorcycle you might have seen two instruments, that is one is odometer and another meter is speedometer. Odometer and speedometer. Speedometer. What does the odometer shows? Odometer shows the total distance covered. Total distance covered by the bike. Altogether, all the distance covered are added subsequently and shows the total distance covered up to that time. But what about the speedometer? Speedometer is the instrument which shows the velocity of that bike at that instant of time. That means, in a particular time, what is the exact velocity of the bike, that is shown by the speedometer. So, that is similar to this. Instantaneous velocity is the velocity which gives the velocity of the object at that particular instant of time. The formula for this velocity, instantaneous velocity, is V is equal to limit del t tends to 0 del x by del t. That is, we are using the limit here, del t is tending to 0, that is time tending to 0. That means, we are approaching towards the instant of that time. So, V is equal to dx by dt, that dx by dt is the differential coefficient of x with respect to time. In order to understand this instantaneous velocity, let us have a graphical form. It is the motion, say OB is the motion of an object, continuous motion. We need to find the exact velocity of the object at point, say P. So, we have to take the tangent of that point, so that we can get, say this is the R, then if we take the tangent to this, we will be having x and y axis. The ratio gives the instantaneous velocity, because del x by del t. So, change in displacement by change in time. So, we can take the point P2 to P1. If we draw the tangent, we can get the velocity. Again change the point Q2 to Q1, again we can get the velocity. If we go on reduce the point, we will be getting to the particular point, say P. In that point, the del t tends to 0. That means, we are getting the velocity at that instant of time. So, if we draw the tangent and draw the slope, we will be getting del x by del t, that gives the instantaneous velocity. Instantaneous velocity. So, we sum up with this today. Today we have seen motion, mechanics. Under mechanics, we have seen the branches of mechanics, that is the statics, dynamics and kinematics. Statics is the study of object at rest, dynamics the study of object in motion considering the cause of motion. Next is the kinematics. Kinematics is the study of object in motion without considering the cause of motion. Then we come to types of motion we have seen. If an object is moving in a straight line, that is said to be rectilinear motion. If the object is moving in a 2D, then it is called planar motion. If an object is moving in 3D, then it is said to be in motion in space. Next we have seen position with respect to x axis, y axis, z axis, and if it is joined with the time, then that is called frame of reference. Next is path length, the actual path traversed by the body. Displacement, it is the shortest line separation between the initial and the final point, and we have discussed about the differences between the distance and displacement. We have seen speed, average speed, velocity, average velocity, and finally we have seen instantaneous velocity also. So, here due to shortage of time, we shall sum up today here. We shall continue in the next class with numericals. Thank you.